Hey guys, today we're going to have a look at completing the square. Now, it's going to be a bit of a confusing process at first, and I'm sure you're going to ask yourself several times as you're doing this, why am I doing this? What's the point? I promise I will explain it to you. I don't promise it's going to be easy, but I do promise it will be worth it. But for now, you need to get the basic skills so that when I give you that explanation, you actually understand what I'm talking about. So let's start with the very basics. By now, you probably noticed that some quadratics are a bit special. This here is a kind of a special quadratic, for example, because when you factorize it, you end up with a bracket multiplied by itself. We could rewrite that in another way. We could say that that bracket is being squared, which is what makes this kind of quadratic a perfect square. But just because it's special doesn't mean it's unique. There are infinite numbers of perfect square quadratics. Here are just a few. If you want to hit pause and try factorizing them, you'll see that you will end up with a bracket times itself, or that bracket squared. Now, obviously not all quadratics are perfect squares. This next one is not a perfect square. It's a two-term quadratic, and I've given you this one in particular because I think it's going to be easier for us to start with, but it's definitely not a bracket multiplied by itself. Now, we want to express this in the format of x plus p squared plus q. See, we know this is not a perfect square, so it's going to have something extra left over. Kind of like when you try and divide a number by a value that's not a factor and you have a remainder, although this is a little bit more advanced than that. So we want to complete the square. We want to express this basically as a squared bracket, but we know there's going to be something extra. So expressing it in the x plus p squared plus q format, where p and q are values to be found. That is, these are going to be numbers. Right. Now, to understand that, maybe it would help if I took this completed the square format and expanded it out to you so that you could see what it would look like as a quadratic. And then we can compare our original quadratic to the expanded version of this to see how we can work backwards to get this completed square. So first of all, we've got this bracket squared. Right, we've got x plus p times x plus p plus q. Now, this q is not going to get involved very much in this expanding of the brackets. It's just going to sit there. But if I expand these brackets out, I get x squared plus px plus px plus p squared. Notice we got the two terms in the middle here. I didn't just do x squared and p squared. I did it following the steps. X times x times p times x, p times p. Okay, now I've got four terms here, but I can simplify. I can group like terms. I've got my two x terms here, which I can group together and make that 2px. And these terms over here, I didn't group them together because they're not the same letter. However, remember that p and q are values to be found. These are going to be numbers. So in the end, these will be grouped together, and that will be the third term of my quadratic. So I've got my x squared term, my x term, and these two together are my constant, my number term. However, in this example here, I only have two terms. I've got the x squared term, which should be pretty easy to work out. The x term, 10x, should be the same thing as 2px. And my number term is 0, which means that these numbers here will add up to 0. I've used some colors here just to make that a little bit clearer for you. So the 10 is the 2p, and the 0 is the p squared plus the q. Okay, so let's try and complete this square. I've got some steps for you to follow, and you're going to want to write these down. So if you need to hit pause to do that, please do. Step 1, make sure a is equal to 1. Well, that's pretty simple. A is the coefficient of the first term, and there is no number in front of the x squared, which means that is 1x squared. So yes, a is equal to 1. It's not always 1. Remember, I'm starting out with the simple examples. I'll explain what you need to do when it's not 1. Step 2, set up a set of brackets to be squared with x as the first term. That sounds pretty easy. It kind of sounds like the way we factorize. Set up two brackets with x in both brackets. Okay. Set of brackets, x is the first term, and I'm going to square that bracket. Good. Step 3, half b and make this a second term inside the brackets. Half b. Why am I going to half b? Here's my middle term, that's b, and I'm going to half it because I'm trying to work out what p is inside these brackets. And look, 2p here will make the middle term. So that's why I need to half b, because I am going to multiply this by 2. Okay, that makes sense. Step 4, work out b over 2 squared and subtract this from the value of c outside the brackets. Okay, I want this to expand out to be this. I know that I'm going to get 2 times this value, which is going to give me my b value. And I also know that when I expand this bracket, I'm going to get the x squared, and I'm going to get the p squared. So that's this squared. But I don't want this. I want 0. So I'm going to add 0 at the end, and then I'm going to take away this. So that's the b over 2 squared. Okay, hopefully that makes some sense. So this is what we're going to do. This is the general format of our completed the square. Let's put some numbers in here so this makes a bit more sense. So start out, step 1, yes, a is equal to 1. Step 2, set out a set of brackets with x as the first term. Okay, that's going to be squared. Step 3, half of b. b is 10, so I'll do half of 10 plus 5. Okay, add c and work out b over 2 divided b over 2 squared and subtract this from c. C is 0, and b over 2 squared, that's going to be 10 over 2, is 5 squared. Okay, now I said this was going to be a bit confusing to start with, but we are off to a good start. Step by step, pretty straightforward. Right, we need to simplify this. I'm not going to expand this out because I want to keep it in this format. I just want to figure out what q is. Okay, so I'll leave the bracket, and I'm going to simplify this. 5 squared is 25, so that's going to be 0 minus 25. And 0 minus 25 is negative 25. There we have it. X plus some number squared, x plus 5 squared, plus q. And q is negative 25. It can be a negative number. Right, let me just show you the check for that to make sure that we are right here and show that I'm not lying about this. Right, so check. First of all, let's expand those brackets. So x plus 5 squared means x plus 5 times x plus 5. And don't forget about your minus 25. So that's going to be x times x, x times 5, 5 times x, 5 times 5. That's giving me my x squared, my 5x and my 5x, which together will make that 10x, looking good, plus 25, which was what I didn't want from expanding out this bracket, which is why I subtracted it here. So this is all going to group together and simplify really nicely, x squared plus 10x plus 0. Squared plus 10x plus 0, exactly like we planned. Okay, let's see if you can try one on your own. I'm leaving the steps here for you. Hit pause if you need to, but you want to try and complete the square with this one. A is equal to 1, yes. Step 2, set up a set of brackets to be squared with x as the first term. Go for it. Half b, okay, and make that the second term inside the brackets. And then work out what b divided by 2 is squared, and subtract this from c outside the bracket. Got it? Okay, let me show you what that looks like then. Got my brackets with x in it. Half of b was 14 divided by 2, 7. And I am going to put this c, which is the negative 8, outside and subtract b over 2 squared from it. So 7 squared from it. Right, simplifying that, 7 squared is 49, so that's going to be x plus 7 squared minus 8 minus 49, which is going to be x plus 7 squared minus 57. That's my completed square. I am done. I know it doesn't look at all like the original quadratic, so you might want to do the check. I'll check by expanding out those brackets. X plus 7 times x plus 7 minus the 57. That's going to be x squared plus 14x plus 49 minus 57, which is x plus 14x minus 8. Perfect, exactly what we were looking for. Now here's another one. If you want to try it on your own, hit pause, but note that this is where b is negative, so watch out for that. The sign is important. Okay, so let's get started. Is a equal to 1? Yes, a is equal to 1. Step 2, set up a set of brackets to be squared where x is the first term. Done. Step 3, half b, so half of negative 4. So half of negative 4, that's negative 2. The sign's important. Step 4, do half of b squared. Now be careful. This is negative 2, but negative 2 squared is negative 2 times negative 2. That's going to be positive 4. So I'm going to work out that that's positive 4, and I'm going to subtract that from the value of c, which is negative 20, outside the bracket. So I'll do negative 20 minus that positive 4. Okay, just simplify that then. My bracket looks good and it's being squared. It's just what's outside that I need to group together. Minus 24. Okay, now again, this doesn't look much like what we started with. So you're going to want to check this at least the first few times you do this to make sure you've done this correctly. Let's expand those brackets out. X minus 2 times x minus 2, and the minus 4 outside, as it wasn't a perfect square. So expanding those brackets, it's going to be x squared minus 2x plus 4, minus the 24, that's going to be x squared minus 4x minus 20. Exactly what we wanted. Great. Okay, here's another one where b is negative. Now maybe you do want to hit pause and try this for yourself. Remember, check if a is 1. It is. Set up a set of brackets where x is the first term and square that bracket. Half b and make that the second term in your bracket. And work out that half of b value squared and subtract that from c outside the bracket. Now if you tried that for yourself, you'll notice that it's a bit tricky here because b is negative 1. I didn't put a number in front of this x, it's negative 1. So half of b, you might think I can't do that. You can. You know that decimal values do exist. It's going to be negative 0.5. Okay, so let's do this. Got my brackets, and I'm going to subtract a half, and then I'm going to add c outside and subtract negative 0.5 squared from it. Right? Simplifying what's outside the brackets, that's going to be 5 minus 0.25, which is plus 4.75. We can have decimal values in these completed square formats. So p is negative 0.5 and q is positive 4.75. Again, this doesn't look like what we started with. Specifically for ones like this, I really want to check this. So I'll check by expanding my brackets out. That gives me x squared minus a half x minus another half x. Together that's going to make minus 1x plus 0.25 plus the 4.75, and that's going to work out to be exactly what we started with. X squared minus x plus the 5. Perfect. So now here's some practice for you. Again, I started you out with some easier ones where you've just got 2-term quadratics. So when you're working out what q is, it should work out to be 0. And then we've got some slightly harder ones. Notice that in all cases, I gave you quadratics where a is equal to 1. I didn't give you any of those difficult ones just yet. But down here, you're going to need to expand these brackets out first. This is not a perfect square. It's not a bracket times itself. So expand it out first, get your 3-term quadratic, and complete the square for it. Same thing here. You're going to need to multiply this out and get your 3-term quadratic and complete the square. Go ahead and hit pause now if you need some time. I'm sure you do. Take all the time you need. Okay, I hope you've hit pause. Here come the answers. Here's the first row, which should have been the easier row. I hope you checked them. Next row. Next. And finally, our challenging ones. Right. Let me know if I have any mistakes there, or if you have any mistakes that you don't understand. I'm here to help. I know this is not the easiest thing to learn.